Hello, it's good to have you here. I'd love to tutor. This question is on page 169 of Functional Mathematics for Senior Secondary Schools, Book 1 by T.M. Asiru et al. The question says ABCDE is a regular pentagon and rectangle AXYE is drawn on the side AE such that the vertices X and Y lie on the sides line BC and line CD respectively. Calculate the size of A, an interior angle of the pentagon, B, angle BXA. Now let's make a rough hand sketch of this pentagon. Now this is a rough hand sketch, so a regular pentagon. So let's label this pentagon A, B, C, D, E. Now it's a ABCDE is a regular pentagon and rectangle AXYE is drawn on the side AE. Now look at AE, the rectangle AXY. So we have the vertices AE, remaining the vertices XY. So the triangle is the rectangle is drawn on the side AE such that the vertices, the remaining two vertices of the rectangle XY, lie on the sides line BC. Now this is line BC, so one of the vertices, which is X, will lie on this line BC and Y will lie on line CD. Look at line CD. Okay, so we have it this way. This is a rough hand sketch, it's not a perfect drawing. So this is X, such that the vertices, this is X, and then we have another line here on line CD. Okay, so and this is Y, so that you have this rectangle AXYE. Okay, this is a rectangle, so it doesn't really look like a rectangle, but that's what it is. Okay, so here we have it. We have our pentagon and then we have our rectangle inside it. So now the question says to calculate the size of an interior angle of the pentagon. Now we know for a regular polygon, we've been told, is stated that this ABCDE is a regular pentagon. It's a polygon. So a regular polygon has all its sides equal. So it is expected that AE is equal to ED as well as equal to DC and BC, and the whole sides are expected to be equal. So now we have that for a regular pentagon, the sum of the interior angles, interior angles of a regular polygon okay, we should say of any polygon, actually, of any polygon, the sum of interior angles of any polygon of n size is equal to 2n minus 4 right angles. Okay, right angles. Now you know that right angles a right angle is 90 degrees. So this is equal to 2n minus 4 times 90 degrees. So now for this pentagon that has been given to us, the sum of the interior angles of this pentagon, the interior angles of a polygon. This pentagon has 5 sides. Okay, this is 1, and this is 2, this is 3, this is 4, and this is 5. The sum of the interior angles of a polygon of 5 sides. Now replacing n with 5, substituting for n, will be equal to 2 into 5 minus 4 times 90 degrees. So that you have 2 times 5 is 10 minus 4 times 90 degrees. So for this bracket you have 10 minus 4 is 6, and then 6 times 90 is 540 degrees. This is the sum of the angles of this pentagon. Okay, this is supposed to be the sum of the angles of this pentagon, but the question says to calculate an interior angle, so just one angle. So since the sum is 540, and then we have how many angles? We have 1, 2, 3, 4, 5 angles, and their sum is 540 degrees. So for one angle, since this is a regular pentagon, the angles are supposed to be equal. So you have that an interior angle of the pentagon, because it's a regular pentagon, the angles are equal. Okay, the interior angles are equal. So an interior angle of the pentagon will be the sum divided by the number of angles. Okay, so 5 going through 540 will give you 108 degrees. So that is our answer for A. And then for B, we've been told to calculate the size of angle BXA. Angle BXA. Angle BXA is this angle located at X. Okay, so now we've gotten an interior angle of the pentagon to be 108 degrees. That means this is 108 degrees. This is 108 from here to this place is 108 degrees. This is 108 degrees, as well as this and this. Okay, so now we, for this triangle BAX, we know one of the angles to be 108 degrees, and then this is the whole of this is 108 degrees. So we need to know what this is. Okay, so we need to get this angle here, we need to subtract this angle from this angle here. Now AXYE is a rectangle. Now let me start from here. From rectangle AXYE, you have that this is AXYE. You have that EAX is 90 degrees. EAX is 90 degrees. You have that angle EAX is 90 degrees. Now for a rectangle, for a rectangle, one of the properties of a rectangle is that each angle is 90 degrees. So if you have AEAX to be 90 degrees, this angle right here also is 90 degrees, and this is also 90 degrees. Okay, and this is also 90 degrees. Now, if this is 90 degrees, if this is 90 degrees, but the whole of this place is 108 degrees. Now it means that this place will be 180 degrees minus 90 degrees, and that is BAX. Okay, BAX, angle BAX is equal to angle EAB is one of the interior angles of the Pentagon located at A. Okay, EAB minus angle EAX, and EAB, that's one of the interior angles of the Pentagon. So angle BAX is equal to EAB is 108 degrees. 108 degrees minus EAX is 90 degrees. So 108 degrees minus 90 degrees will give us 18 degrees. So we have that this angle right here is 18 degrees, and of course 18 plus 90 will give you the whole of this angle, which is 108 degrees. So now that we know this angle for this triangle BAX, we know this angle and we know this angle. Okay, and we are left to this unknown angle that we've been told to find. So we have that from triangle ABX, we have two known angles and one unknown. We have 18 degrees plus 108 degrees plus angle BXA. Okay, BXA, which is this angle that we've been told to calculate, is equal to 180 degrees. Sum of angles in a triangle. Sum of angles in a triangle. Okay, so we have 18 degrees plus 108 degrees will give us 126 degrees. 126 degrees plus angle BXA equal to 180 degrees. So we have that angle BXA is equal to 180 degrees minus 126 degrees, which is equal to 54 degrees. So our BXA, which we've been told to calculate, is equal to 54 degrees. So that's it.